summation of vectors. So vector algebra is now started. First, we have to discuss the graphical method, and then after we will discuss analytic method. Okay. Now, summation of vectors. I already mentioned this thing. Summation, subtraction, or multiplication of vectors, that is nothing but the special type of combinations of vector physical quantities. Or we can say when more than one vector physical quantities are effective, then what will be the result? That is nothing but the special type of combinations of vector physical quantities. And these special type of combinations are represented as summation of vectors, subtraction of vectors, and multiplication of vectors. અને આની આપણે ડે ટુ ડે લાઈફમાં જરૂરત ઊભી થાય છે એટલે આ આખું એલ્જીબ્રા આ રીતે ડેવલપ કર્યું છે. સાયન્ટિસ્ટ ન્યૂટન as well as scientist Leibniz developed this algebra. Okay. Now see, let's understand this summation of. So summation of vectors is carried out by two methods. One that is called triangular method, another one that is called parallelogram method. And the name of these methods are given as per the graphical representation gives the triangle as well as parallelogram as a figure. So we say these methods are triangular method and parallelogram method. Suppose as shown in figure, we have two vectors, vector A and vector B. And we want summation of these two vectors. So here, prepare a vector which one is parallel to A and having magnitude exactly equal to A, that is vector OP. But as we discussed equality of vectors, when vector A and vector AP both are in the same direction and magnitude wise same, then we can say vector OP itself is vector A. Then after from the head of vector A, prepare another vector PQ, which is in the direction of B, and the magnitude of PQ that is equal to magnitude of B. Then we can say vector PQ itself is B. In short, here, place this B on the head of A without changing its direction. એવું જ કર્યું કહેવાય ને, આ આપણે કર્યું એમાં. બરોબર છે? Okay. Now prepare a vector joining to the tail of first one to the head of second one. So this vector prepared here OQ in the figure, that will give you the summation of these two vectors. So vector OQ, that is called vector A plus vector B. And here see, this triangle is formed, so this is called triangular method. Now, in another way, we can find the summation by parallelogram method. In that, what we do? Vector A and vector B both are represented from the same origin. Means tail of both the vectors should be represented from the same origin. Here, vector OP, that is vector A, and vector OR, that is vector B, both are represented from common point O. Now, by considering vector A and vector B as two adjacent sides, prepare a parallelogram. So now the parallelogram is prepared OPQR. Then the diagonal from the origin, this OQ, that will give you the summation of these two vectors A and B. Now see here, actually the triangular method is subset of this one, we can say. See, here in parallelogram, these opposite sides are parallel to each other as well as are with same length. Means we can say this thing, if here we prepare this vector PQ, then we can say vector PQ is vector B. Now, to this triangle OPQ, if we apply this triangular method for the summation, then we can say vector OQ, that is A plus B. Clear? But suppose we think on this side. So vector OP, that will be equal to vector RQ. So we can say vector RQ is A. Now if we apply the triangular method, now this one is vector B, and from the head of vector B, vector A is represented. Then the vector joining to the tail of first one to the head of second one, that is vector OQ, that will give you the summation of this and this. So you can say that is B plus A. But here if we take A plus B or we take B plus A, our answer is same one, vector OQ. So we can say the commutative law holds in the summation of two vectors. Clear? Commutative law holds in the summation of two vectors. Means if you take A plus B or you take B plus A, your answer will be same one. Now, suppose we want summation of three vectors or four vectors or five vectors, then simply extend this triangular method. In this method, what we do? We place a second vector from the head of first one. If you want summation of three vectors, then do this thing. On the head of first vector, represent the second vector. From the head of second vector, represent the third vector. It implies that arrange the vector head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, like that. And finally, the vector joining to the tail of first one, जो અહીંયા કર્યું હતું ને tail of first one to the head of second one. હવે અહીંયા જો આપણે 3, 4, 5 વેક્ટર લીધા હોય, then same thing. Prepare the vector joining to the tail of first one to the head of last one. That will give you the summation of all those vectors. And here also we can observe this thing. Suppose we want A plus B plus C. So in that, first suppose we take A plus B, and that resultant is suppose OQ, then it is a sum up with C, then we will get OR. But suppose first we take B plus C, so that is result PR, and then we take the summation of A and this one, then result is OR. Means if we take A plus B, and then after if we sum up it with C, or suppose we take summation of B and C, and then we take the summation of it with A, answer will be the same one. Answer will be the same one. And in this way, suppose you have n vectors, then no problem. Arrange all those n vectors, head, tail, head, tail, head, tail, head, tail, head, tail, and then finally prepare the vector joining to the tail of a first one to the head of last one. You will get summation of all those vectors. Now here remember one thing. Suppose you are arranging all the given vectors, head, tail, head, tail, head, tail, head, tail, head, tail, and at that time, suppose the head of last vector superposed to the tail of a first vector, then what will be the summation of all these? What will be summation of all these? Give me answer. 0. See here. Three vectors are arranged head, tail, head, tail, head, tail. And then after finally we have to prepare a vector joining to the tail of first one to the head of last one. પણ હવે જો આ લાસ્ટ નું હેડ જ જો આની ઉપર અહીંયા પડી જાય તો પછી વેક્ટર બનાવશો કેવી રીતે? નવો વેક્ટર ના બને, કારણ કે પહેલાનું ટેલ અને છેલ્લાનું હેડ સુપરપોઝ થઈ ગયું એટલે ક્લોઝડ લૂપ ફોર્મ થઈ જાય. તો આવી રીતે જો એરેન્જમેન્ટ થઈ જાય ને વેક્ટર્સની તો ઓલવેઝ યાદ રાખવાનું કે સમેશન ઓફ ઓલ વેક્ટર્સ that is 0. The resultant of all these vectors, that is 0. Clear to all of you? Any doubt, any question in this one?